Good afternoon, everybody. Today we're going to take a look at the second Autodesk Inventor 3D model creation, which is going to be the right angle brace. So to take a look at it first, I'm already in the Course Hub homepage. I'm going to go to Content and select the Introduction to Autodesk Inventor Solid Modeling module, select our image. So this is it right here, the right angle brace. Now this one's a little more complicated than the die punch. We have to take a look at this and look at the dimensions that we have to create it. Now, there's some things that are not given to us, which is, for example, this vertical surface that has these two holes, where it begins and where it ends before it becomes an angular surface is not given to us. They do give us the height in total. They give us the total length. They give us the thickness of this vertical surface at the bottom, which is 5/8. But they, again, do not give us the length of this horizontal surface where these two holes are. They give us the length of this flat bottom before it becomes on an angle of 30 degrees as 1 3/8, but they don't, again, we can't assume that from here to here is 1 3/8 because it's not. We can't make any assumptions where we don't see any dimensions. So there's enough information given to us that we're able to constrain the sketch to extrude it, and I'm going to show you how that is. Now these units are different. These are listed in fractional units, which is fine. We can input fractions into Inventor, no problem. So this is going to be the last time I show this in the video. When I create these models, I always have my iPad open next to me, and I'm in the hub on my iPad, and I'm looking at this image while I draw it. And that's how I recommend you do it. It's really annoying to have to toggle back and forth between two screens on one monitor, and I won't be doing it in my lessons. So I really urge you to adapt my method of doing things right at the beginning. But moving on, so we're switching into Inventor. We're going to be going up to File, New, and making sure that English is selected under Templates, and we're selecting Standard inch.ipt and hitting create. So to get started, we're going to be drawing the view that shows the profile of the right angle brace. So that's the easiest way to model this part, and I think you'll see and understand it as I get started. So we're going to go 2D sketch, start 2D sketch, select XY plane. This is the best plane to start with, in my opinion. So I'm just going to pan this. Here's 0, 0, where X and Y intersect one another. I'm going to move this a little down here so I have some room to see my sketch as I build it. So I'm going to be starting with the line. And I'm going to be starting at 0, 0. And I'm going to left click. And all I'm going to do is sketch the profile. I'm not actually trying to sketch this with great accuracy. I just want to get the shape of it. So I'm just going to be drawing a horizontal line here. I'm going to zoom out a bit with my wheel, my third button, the middle wheel. And I'm just going to be drawing a line on an angle. I'm going to be coming up vertically, drawing a line horizontally, perpendicular, coming down. I don't want to bring this down right in line with this point. I want to leave it a little bit higher. Click. Come down on an angle. Try to get this parallel. You see when I move my mouse like this parallel symbol pops up. That's the best way to sketch this. So come down like this. And I want this to not be in line with this point, but come a little further. And then click. You'll want to pick up the Y value right there on on parallel and come down, click 0, 0, and that will bring you back to where you started. Right click, left click OK to end the line command. So you're going to notice that I've got the profile sketched, not with great accuracy, but I did take some care in its creation. It looks green, except these two lines here. These two lines look purple. And why are these lines purple and these ones green? Well, green geometry represents that the sketch has not been constrained. These two lines here are purple because they're connected to 0, 0. So as far as Inventor is concerned, those lines are anchored, and even though they're not dimensioned, Inventor considers them constrained. So that's why they're purple. So basically, as we constrain the sketch, in other words, solve the sketch, the right angle brace is going to remain anchored to 0, 0, which is what we want. So you always want to start all your sketches on 0, 0. You don't want to just start anywhere on the screen. It's going to save you work to do it the way I'm showing you. So to get started, we're going to use our general dimension tool here in our ribbon, in our constrain ribbon. And I'm going to select this horizontal line and pull a dimension off and drop it by left clicking it. So this needs to be inputted as a fraction. The length of this line is supposed to be 1 3/8. So I can type 1, leave a space, and type 3/8. Once I've done that, I can hit the check mark or hit enter, and it's going to constrain that line to be the correct length it's supposed to be. Moving on, this vertical line needs to be constrained to 5/8. So I can type 5/8, enter. Now as I do this, what do you notice? This line, which was no longer purple, which was no longer green, has now become purple. Because as I solve or constrain the sketch, all the line geometry should become purple by the time I'm finished. That way I know that there's nothing left to solve and constrain, and I can extrude and get some depth on the z-axis. So moving onward, we are going to set the angle for 30 degrees. So I'm going to select this line and this horizontal line, change this to 30. And next, we're going to create the height. The height is shown as 2 3/4. So I'll select this horizontal line and this horizontal line. Type in 2 space 3/4. Check mark. Now it looks like it's becoming a bit disjointed here in shape, but again, I'm not quite finished yet. So it should all make sense by the time I'm finished. Next, I'm going to input the length, which is 4 inches even. So I'm going to select this vertical line, drop the dimension, key in 4, hit enter. All right, so because this line was sketched parallel with this one, which is constrained, by the time I fix the width, this should all solve now with my next dimension. So I'm going to select this dimension, this line, and this line, and type in 5/8 for 5/8 and hit the check mark. And it didn't do what I said it was going to do. Now we're almost done. This last line here should not be green. So we have one more dimension actually we have to add to this that I forgot. And we need to add, it's already parallel, we just have to add the thickness of it, which is the same as this value and this value. So the thickness is uniform throughout, so it's 5/8. So let's select this line and this line and update that to be 5/8. Check mark, and now everything is solved. So as you see, we didn't need to know the length of this line. And we didn't need to know the length of this line. We were still able to solve it. But what happens if I try to run dimensions on a sketch that's already constrained fully? It tells me what that is. It's 1.208. Well, the sheet never never told us that. How could we have ever have known? But when I try to drop the dimension, it gives me a warning. It says adding this dimension will over-constrain the sketch. Choose accept to create a driven dimension. Well, I could accept it, but there's no point. So I'll just cancel that. Same thing here. If I select this vertical line and I hit accept, it'll create the dimension. It puts it in brackets. It's driven. It doesn't really affect anything, so there's no point in actually having these dimensions here. I want to actually hit escape, and I can't, because if I hit escape, I'm going to cancel my video recording. I'm using video recording software, so I'm used to hitting escape, to exiting commands, and then deleting things, but sometimes things will look a bit clunky because I can't use that button, which I'm used to. So now that I've hit the finish sketch, this is going to bring us into an isometric view here, right? So here's our front view of the sketch. We have no depth to the right side. So we'll just hit the corner of the cube, put this on an isometric 3D view, hit extrude. We're going to give it depth, make it a solid on the z-axis. So it doesn't give us an overall width that we can extrude this with. It gives us 3 fractions. It says 9/16, 1 1/8, 9/16. Now, before you freak out about having to add fractions together, or, you know, grabbing your calculator, this is one of the beauty parts of Inventor. I can input all the fractions like I would in math class, but Inventor will solve it for me. So I'll say 9/16, and I'll go shift to get the plus symbol, and I'll go 1 space 1 1/8 plus 9/16. So there we go. We can just put all the addition of the fractions in the distance space and then hit OK. And we have it. Moving on, we have to add some holes to this. We have 2 holes here. We have 2 holes at the bottom. So we're going to create a 2D sketch. And we're going to start here or here. It doesn't matter. I'll start on the bottom. Select this face, and Inventor orients it to the top view in a 2D perspective for me. And what I can do is pick my circle. I can just drop 2 circles on here. I can, if I just touch the center and not click and come this way, I can keep them on the same X value. So I'll just draw another one. Now we're going to dimension them with our dimension tool. So select this circle. We're going to constrain these to 7/16 as the iPad image tells me. 7/16, check mark. Do the same thing here, 7/16. And now we're going to constrain it on X and Z, as you see here. So we're going to go dimension from here to here. The iPad image tells me it's 11/16. Check mark. This side as well. And from here to here, it's 9/16. Now, see what happens? This goes purple because it's constrained. It needs 3 dimensions to constrain it. It needs to know the diameter. It needs to know the value on X and the value on Z in this case. And then lastly, we can run a dimension from here to here. And it can be 1 and 1/8. Check mark. All right, so we're going to hit finish sketch. We're going to hit the extrude. We're going to select both of these holes, but that's going to want to extrude it with mass and send it up. I don't want that. I want this to cut holes. So this is set to join. We'll switch this to cut. And what we should do is actually, the correct way is to set this to all, meaning it's going to go all the way through from top to bottom. It looked like it was going to do that anyway, but this is good practice. So we'll hit OK. And if I go into a free orbit, you can see that those holes have been cut through the solid object. Okay, let's practice that again. One more time on this surface to finish this model. So 2D sketch, select this surface, which will orient it into a right side view, a 2D perspective to sketch on. Use our circle tool and draw. Drop 2 circles here. Run our general dimension. The image I'm working off of says there's 4 holes, 7/16 diameter. So again, these are going to be the same size. They're 7/16. Check mark. And it again, this one is 9/16 from the right edge. And from here to here, I could go from here to here 1 1/8 again. Or I could have left this dimension out and I could have gone from here to here 9/16. It would have given me the same result. And then one last dimension from here to here, from the top surface to the center point of the hole, is listed on the top. It's different. It's 1/2 inch. So 1/2. Same thing here. 1/2. Okay, and we're constrained. That dimension went crooked for a bit, and after I inputted the 1/2 inch here, it straightened it out again horizontal. So that's how that should look. Hit finish sketch. On the iPad sheet, it shows a center line running from the center of each of these holes, and that center line runs all the way up to the center of this circle on both of these. So this is how I know that these holes are supposed to share the same 9/16 on both sides, and 1 1/8 in the middle with its top counterparts. Right? Center lines help communicate information in a mechanical drawing. We're going to talk more about center lines later. So now we're ready to extrude. Same thing. Select the 2 profiles. Change this from join to cut. Set distance to all. And hit OK. And there we have it. That is it. That is the right angle brace fully modeled correctly. So last step, save this. Go to File, go to Save As. I'm going to change this to a different folder, TDJ3M Solid Modeling Lessons. Make sure you're saving these things to a specific location on your computer so you know where to find them later, especially for drawing file creation. Keep your models and your drawing files together. Save yourself some headaches later, please. Hit save, and that is it. I have the part saved. I'm ready to create a drawing file for this, but we're not going to do that quite yet. The next lesson we're going to take a look at is drawing the control bracket, which is the final model on the sheet. Once I've shown you how to model the control bracket, we're going to be ready to create drawing files for both of these models. And that is it for today. So I hope you enjoyed that video. I hope it was helpful. I want you to try this on your own at your computer station and let me know if you have any difficulty with this. Take care for now and have a great day.